Okay, last part of 4.6, damped trigonometric functions. Let's start off with the basic sine wave. I decided to do this video entirely in Sketchpad because there's a lot of things that we need to see dynamically with the function. You won't be graphing these freehand, you'll be graphing with technology and interpreting them with real-world examples. Notice I have the sine function graphed here. That's the same color as this, just basic white. Notice I have my trig axis in terms of pi. Actually, pi over 2, pi over 2, pi, 3 pi over 2, and so forth. So I'm going to make this go left and right just so you get a sense of what's here on the graph. Now, I'm also going to graph this next function. Oops, not that one. We'll talk about that in a second. Let's graph the function g of x equal to x. Now, that's just the basic parent linear function, remembering that this x-axis is in terms of pi, so it doesn't line up at the exact values because we're talking about for 1 equal to 1 and so forth. All right, now a damped trig function is saying that we have some damper, in this case, x. Now, damped function on sine, this on this would actually cause this to increase. So, if I were to multiply these two functions, then multiplying the two functions is simply saying whatever the output of sine is, we're going to take that and multiply it by the output here. Note that sine is never greater than 1, nor is it less than negative 1. It's always between the two values. So the multiplication of these two things, the product of x and sine x, can never be bigger than 1, nor can it be less than negative 1. In fact, when it equals 1, the maximum, and negative 1 on sine, then it's going to equal the graph of g of x equal to x. Except for when it's equal to negative 1, then it's going to flip on the opposite side. So let me go ahead and graph a corresponding function, and we'll call this negative x. Now this corresponding function is related to the g of x. And the reason why we need this is because when we have a negative 1 output, when that gets multiplied by sine x, then it's going to be on the negative side. All right, let me go ahead and graph the next graph, and I'll explain to you what is going on here. I'm going to shrink this down so we can explore it dynamically. Now, where the output of sine was 1, it gets multiplied by f of x. So 1 times sine x is equal to, 1 times... 1 of the sine times g of x is equal to whatever g of x is. So that means it lines up with it. In fact, at every crest, there is equal to g of x. At every trough, it's equal to the negative value. So when it's down here, or the flip of it, only in the positive, first and fourth quadrant, So when this is negative 1 is the sine, that's f, that gets multiplied by g of x, then it's just equal to g of x. And it just rotates between those two values. The intercepts of sine are still the intercepts of h of x because that's when f of x is equal to 0. So that's the basic idea of damped trig functions. Damped just means it's changing the amplitude. All right, let's go ahead and change the... in fact, I need to change this a little bit and make it not just negative x because I need to make it dynamic. I'm going to make it negative g of x, even though in this case it happens to be the same. Alright, let's change up some things a little bit. Still going to keep sine x, but in this case I'm going to change my damper. Instead of it being x, I'm going to do e to the negative x. Remember, e to the negative x is an exponential function, but in this case it's going to decay. That means it's going to get smaller and smaller as it goes off in the positive x-axis. And that is what we should have been expecting. Notice we have our basic sine wave. Our bluish green here is the h of x, it's our damped trig function, and this purple and the other green one is our dampers. Let me go ahead and hide the original sine function because it might be a little bit distracting. All right, let me explode this a little bit so that we can see a little bit more about what's going on. Notice wherever the maximums and minimums of sine were, that's where it hits, the damped trig function hits the damper, which in this case is e to the negative x. Awesome, let's just explore one more to get a basic sense of damped trig functions. In this case, we're going to change the input of sine and multiply it by 4, which means the period 2 pi divided by b becomes 2 pi divided by 4, which is pi over 2. It's going to be 4 times as often. All right, let's come over here and change the damper. Instead of e to the negative x, we're going to change it to e to the x. Instead of being a decay function, this is going to be an exponential rise function. That means it gets higher and higher and higher as it goes off to the positive x-axis. Let me go ahead and manipulate this a little bit. Just like the ones from before, the crests of sine are where the damped function hits the damper function, which in this case is e to the x. And that is damped trigonometric functions.